Hello and welcome to SDN Tech Forum. In this video, I'm going to talk about one of the protocol which we use on everyday basis, but it's so common that we don't pay much attention about the functioning of it. So the topic of this video is DNS, or domain name services. Domain name services is a client and server architecture. It helps you to resolve IP addresses against a FQDN, fully qualified domain name, or a website name. Commonly you can say as a website name, right? So when you type www.google.com or sdntechforum.com, then your computer has to resolve the IP addresses because computer only understand the IP address, right? These domain names or FQDN are for common man understanding. So what is a FQDN? FQDN is your host name plus domain string. So host name can be your web server, and domain name is like a google.com is a domain, SDN Tech Forum is a domain, .com, .edu, these are the domains, right? So, and what is a domain? A domain is a collection of name servers. So many name server responsible for their domain and subdomain, they consist one domain. So let's understand the name server, which is like very critical to DNS. A name server is a database server which stores info about domain and devices. It answers resolver query by pointing to other name server, or it can answer that query with its own local database. So when you type some domain like www.sdntechforum.com, it goes to its name server, and name server can reply back based on its own local database, or you can point you to the another name server. So name server, they are typically couple of different type of name server. Authoritative name server, as name implies, it is responsible for that particular domain. That means it is authorized to answer resolver query for that particular domain. A zone can have multiple authoritative name server, and a best practice is at least have two name server, so that if one goes down, you still have the redundancy. And how it works, you have a primary name server which stores the master copy of all the zone data, and rest are, and other servers, name servers are secondary or tertiary, and primary is the only one who maintain the master copy, and it is the responsible to replicate this master zone record to other standbys or secondary name servers. Caching name servers, again, as name said, that this caches the information. That means this is not authoritative, but it is the one which get the answer from authoritative name server first, and then cache this information so that next time it can reply looking at its own database. Forwarding name server is a method where you actually bypass the normal resolution process, and you simply point it to a particular name server. So you don't go through the whole normal query chain. You simply forward it to one particular name server. So what is zone? We talked about zone in earlier slide, right? So the zone is a section of DNS space managed by the single authority. A .com, a .edu, a .net, these are all example of zone. Generally one domain is one zone, but one zone can have multiple domains. So you can, as you can see in this picture, and I'll give example of my own my domain only, which is SDN Tech Forum. So you can see that I have sdntechforum.com, which is one domain, but under that I can have level 2 zones also, which is blog.sdntechforum. And in this picture, which I copied from internet, you can see that on the very top you have DNS root zone, and I'll talk about what is DNS root zone in upcoming slides. But root is like it's at the top level of the zone, and then you have different level of zone. So on the first level you can see that .com, .edu, .gov, .net. Second level of zone can be like Google, Cisco, and likewise. And then you have subdomain also, like SDN Tech Forum has a blog.sdn Tech Forum, or Google has a drive.google.com. So you will have subdomain. Type of zones, so different type of zone, as you can see, but mostly it's like a two type of authoritative zone, a forward mapping zone and reverse mapping zone, and their function is pretty clear. Forward mapping zone, it just simply maps name, website name to the IP address. Reverse mapping zone do the reverse of it. That means it maps the IP addresses to the name, right? So why do we need reverse lookup? Some applications, network applications, they require reverse lookup to validate that this is the right or authorized name server, and troubleshoot monitoring for those purposes. But for human readable purpose, we need forward mapping zone. Then on other side we have delegated zone also. So delegating, that means a name server can delegate the authority of name server, authority of subzone to other name servers. So if a name server is primary for sdntechforum.com, it can have a dedicated name server for subzone, which is blog.sdntechforum, and hence I can have a delegated zone also. So now we understand what is name server and what are the different type of zone. Let's dig into how the DNS entries looks like. So first we'll see a DNS record. So whatever zone and all this information we are talking, they are stored in the DNS server as a record. So this is a simple record format looks like. So you can see sdntechforum.com. Class is IN class, internet class. This is a record type A, alias, a record type, not alias, and IP address. So SDN Tech Forum will resolve to this particular IP address, and A is your host record. Record begins with FQDN. So I am just putting all the information of different fields. It begins with FQDN. IN is the most common class, internet class. So this is the most common entry here. A is the record type. We'll see what are the different record type. And fourth field is data, and this field's value depend on the record type. So in very general sense, it is always IP address. But if the record type is something else other than A, in some cases it can be it may not be IP address, and we will see what are those cases. So now let's see different record type. What are the different record type? So the first record type is start of authority, or SOA as we call it. It exists in every single domain. For every single domain, at least you will have SOA record. SOA provide information used by other name server to ensure they carry up-to-date information about the zone, because name servers are responsible for zone records, right? So SOA record has all this different attribute which make sure the records are up to date. So looking at the field, you can see, so first of that you have domain, then the primary name server, contact address. If you want a responsible party contact address, you can mention it here. Serial number. The serial number is not to confuse with a device serial number or something. It just simply says how many changes happen. Then the refresh time, retry time, expire time. If you have primary and secondary, then a slave name server stored this info for expire, and then it can take over. Minimum TTL is a caching time, how much time you are going to cache this information. So now let's dig into different different record DNS record type, zone record type. The first and foremost or most common is A or quad A, AAAA, 4A. We fondly call it quad A. A or quad A record is a host record. It is most common one. It translates computer's name or a website name to an IP address. So A record is for IPv4 address, quad A is for IPv6 address, because IPv4, IPv6 is four time multiple of IPv6. That's why they decided to put it that way. You can see A record will look like simply like this: your website name, internet class, record type, and then IP address. Then you have the pointer IP, PTR record. It translates IP address to its name. So it's reverse mapping basically. So you can see that it actually read the website address in reverse format and resolve to a website name. Name server record. it binds the DNS domain hierarchy together. So basically, you may have different server, right, for a particular domain. So it will tell you that what are my which are my name servers. So SDN Tech Forum, they will resolve to this particular web server as NS1 SDN Tech Forum. So it's your actual web server IP address. MX record, it is used for mail exchange, SMTP. It returns the name of mail server responsible for requested domain. So if you have a domain which has a IP address also, so you want to resolve your mail exchange server IP address, or exchange server host name, then you need to have MX record. So again, you can see SDN Tech Forum, they have this MX mail exchange server which is pointing to this particular mail exchange server. CNAME record is very interesting one. It is like canonical name or alias. So if you have it's like alias, so you have a very common name and then behind the screen you have a complicated name which is difficult to remember, then you can do a alias kind of thing. So you can see that my actual web server where SDN Tech Forum is hosted is web server 123.sdntechforum.com, but I don't want my user to remember this long web URL. So I put something easy for them, SDN Tech Forum, and behind the scene this is my actual host name. Text server, it stores general purpose text, and service record. Service record is very important one. So it identify a host that will support a particular service. So you may have multiple type of service like FTP service or HTTP servers or some kind of like database server. So it actually identify that particular host. Microsoft AD uses server record. Now for the demo part, we are not going to run a live demo, but I'm going to walk you through how the DNS records and zone entries look like. So this is my bind DNS server running on Ubuntu server, and as you can see, the zone file is maintained at etc/bind name.conf.local, and if you look at the content, what I have is some security parameters and then the zone. So my first zone is asdna.cisco.com. This is the master zone, and the most important thing is this is my zone record location or the host file. So now let's expand the host file. Here you can see the different DNS records. So the first is SOA records, start of authority, and then the different parameters for my DNS server, like for DNS records, the different parameter, what is the refresh time, what is the retry time, expire time, cache time, and all those things. Then the individual record itself. So you can see that I have the host record for my DNAC, ICE, WLC, and all those, and these are my AP records, host file for the AP, and also the text type records. So this is how a typical DNS zone records and record entry look like. So now, as I spoke earlier, I want to tell you or discuss something about the top of the DNS hierarchy, the root server. So root server is at the very top level, right? So it is a in the hierarchy you have seen a dot, that is you can consider as a root server. So root server, there are 13 root server deployed globally, and starting from A to M, so 13 root servers, and out of that 13 root server, CFIJKM, they are any cache type. That means they are not one particular server for that, they are using the same IP address, but they are very well distributed. So this root server, they are maintained by IANA, or different organization are responsible for maintaining that. So if you simply go and do ns lookup for a.rootserver.net, you can see the IP address associated with that. So root servers are the one which has all the top level domain name information, and it can tell you that if you want to get a .com address, where you need to go, and under that .com server, that is going to tell you the authoritative name server IP address. And then once you query authoritative name server, you are going to get the actual IP address for the website. So this is a simple diagram, or which is available from internet, and it shows you a complete flow of how a DNS query is resolved. So you can see it's a busy picture, but on very high level, a user, when he or she want to reach a particular server or particular website, she will query that, she'll put that address in her browser, and it is going to send a resolution request to the local resolver. And if the information is available in cache, you are going to get a reply quickly. Otherwise, you are going to go to your local name server or ISP configured name server, and ISP name configured name server again will look first locally and see if the information is cached. Then the query will be answered immediately. Otherwise, it's going to send the query to the root server. Root server is going to reply you back with that TLD, top level domain name authoritative server. So if the query is for .edu, you are going to get a reply from root server. Then you query back to that edu server. Edu server is going to send you a reply for that. And if it is a subdomain query, you actually go ahead and query the subdomain or delegated server, and likewise you are going to finally get the final IP address for your website. And then user is send the message direct to